Here, let's start next problem. A beam of rectangular cross section 200 mm by 300 mm. It is subjected to shear force of 48 kN. Calculate shear stress at top layer and at a distance of 50 mm, 100 mm from top layer. Draw shear stress distribution line. Here in this problem, section is given. Section having width and depth 200 mm by 300 mm. Here width is 200 mm and depth is 300 mm. Section is rectangular. Then it is subjected to shear force. Means the value of shear force F, that is 48 kilonewton. Calculate shear stress at top layer and at a distance of 50 mm, 100 mm and 150 mm. Means we have to calculate Q50, Q100 and Q150 from top layer, draw and also draw the stress distribution diagram. That is the problem. Here the solution is very simple. First, given data, you just write that data, whatever data or information provided in the problem. Width is provided, depth is provided, section is rectangular, shear force is given. Then at a distance of 50 mm from top layer, at a distance 100 mm from top layer, at a distance 150 mm from top layer. Here in this problem, we have to calculate shear stress at top layer. Distance is provided 50 mm, 100 mm and 150 mm from top layer. Then we have to calculate shear stress at the top layer. Here, to first find shear stress at the top layer, very simple way to calculate shear stress at the top layer. That is the first of all, Y1 150 mm from neutral layer. That value is provided. Then here we calculate a shear stress at 150 mm. Okay. Here in this problem, I just draw the diagram. This is a rectangular section. Then this is a width. It is represented by 200 mm. And this is the depth. This is the depth. Depth is given 300 mm. Okay. Then here, this is the neutral axis or neutral layer passing through the centroid neutral axis. Okay. Then here we have to calculate to find shear stress at top layer. Given data. Here in this problem, data is provided. B is given 200 mm. B is given 300 mm. Shear force is given. That value is 48 kilonewton. 48 into 10 raised to 3 Newton. Then section is rectangular. Then first we have to calculate shear stress at top. That is the distance provided by 150 mm. Okay, that is 150 mm. Y1. Then apply the formula. Therefore, shear stress at 150, that is equal to formula 6F upon VDU V square upon 4 minus Y1 square. In this problem, we have to given data. That data is width of the rectangular section, that is 200 mm, depth of rectangular section, that is 300 mm, shear force, that is 48 kilonewton, that is equal to 48 into 10 raised to 3 Newton. In this problem, we have to calculate shear stress at the top layer. In the first, we have to calculate shear force at the 150 mm because the depth is 300 mm and distance from the neutral layer to the top layer, that will be 150 mm. Then first we calculate the shear stress at 150 mm. That will be equal. That will be 6f upon BD cube in bracket d square upon 4 minus y1 square. This formula is applicable if we have to calculate shear stress at particular distance from the yoke axis. Then we put up the value 6 into 48 into 10 raised to 3 divided by t is given 200 into t is given 300 into 300 here divided by 4 minus 150 bracket complete. Okay, just do the calculation and finding the value will calculate that value will be 0.66 Q150 that is equal to 0. Okay, that is the final value Q150 that will be equal to 0. Then in second thing we calculate shear stress at 50 mm from top layer. Shear stress at 50 mm from top layer. Okay. Then we calculate shear stress at 50 mm from top layer. Then that is wide, that is 150 minus 50, then that will be 100 mm. Means this is from top layer, that distance is given, this distance is provided, this distance is given 50 mm. Okay, then total is 150, 150 minus 50, then remaining is, this is the y2 distance, y2 that is equal to 100 mm. Okay, that distance will be 100 mm. Then here shear stress at 50 mm, we just put up the value Q50 that will be equal to 6 into 48 into 10 raised to 3 divided by 200 into 300 cube into 300 square divided by 4 minus 50 here. Okay. Just we do the calculation. The calculated value is 0.66 Newton per mm square. That is the value. This value is for Q50. Then here, once we calculate the shear stress value, this is the shear stress at 50 mm from the top layer. From the top layer, that value will be calculated. Here, if you see here, that distance is 150 mm. Then from the top layer, that distance is provided 50 mm. Then 150 minus 50, the remaining distance, that is y2, that is you will get 100 mm. Okay. Then we have to calculate shear stress at a distance of 50 mm. That will be equal to same formula applicable for finding out the values of shear stress at 50 mm. 6f upon PD cube into bracket d square upon 4 minus y2 square. Okay, we just put up the value of f, d and y2, and then you can calculate shear stress at 50 mm. Then finally you will get that value Q50 that is equal to 0.66 Newton per mm square. That is the shear stress at 50 mm. That value of the shear stress at 50 mm. Okay. Then next we have to calculate shear stress at 100 mm from top layer. Third one, shear stress at 100 mm from top layer. Okay, that will consider y3, that is y3. Then how to calculate y3? Then total is 150, that is 100 is like this distance is 100. Then 150 minus 100, remaining is y3. Okay, then 150 minus 100, that will be 50 mm. Okay, means that here is the total axis, this value from neutral axis, that is 50 mm. Then here we sorry here 100, okay, because this 100 mm from neutral axis, okay, that value will be neutral axis. And here in this problem we have to calculate, this is very simple way to calculation. In this problem we have to calculate shear stress at top layer from the neutral axis. In the first, whatever data, rectangular beam, oh, sorry, rectangular section having width, depth, inner force that is provided. This problem, first to calculate shear stress at top, that is y1, that is 150, because the depth of rectangular section having 300 mm, and from the neutral layer that distance is 150 mm, means distance between top layer and neutral layer. That distance is 150 mm. Then here, for our sake of convenience, we considered as y1, that is equal to 150 mm from the neutral layer, from neutral axis or neutral layer. Here, the formula is applicable, that is Q150, that is equal to 6F upon 22 into bracket d square upon 4 minus 5 square. Then we just put up the value of the known values that will be provided, that is provided in the problem. Rectangular section having width b and depth b and shear force. Okay, that all the values are given in the problems. So we just put up the value here. Y1 that is the distance between the neutral axis and the most extreme layer, means top layer here particularly. That distance is 150 mm. Okay. Then we just put up the value and we easily calculate the values of shear stress at 150 mm. That will be 0 because maximum shear stress will be generated at the neutral axis or neutral layer. Here, second, we have to calculate shear stress at 50 mm from top layer. We consider distance from the neutral axis to top layer. Here, 50 mm is given from top layer. Okay, the total distance is 150. 150 minus 50, the remaining distance is 100 mm from neutral axis. Then that is considered as y2 for our sake of convenience. Then shear stress at 50 mm, that will be equal to same formula is applicable here. Okay. Then we calculate shear stress at 50 mm. That value will get 0.66 Newton per mm square. Once we calculate shear stress at 150 mm, shear stress at 100 mm from the neutral layer, then in this problem we also calculate shear stress at a distance 100 mm from top layer. Then we consider 100 mm, the total distance is 150. 150 minus 100, the remaining distance is considered y3, that is distance between the extreme layer and the neutral axis. Here, that will be layer, okay, and that distance is provided in the problem from the top layer, that is 50 mm, 100 mm. Here, shear stress at 100 mm from top layer, that is y3, that is 150 minus 100, that is equal to 50 mm from the neutral layer or neutral axis. The same formula is applicable here. That formula is 6F, that will be Q at any distance, that will be equal to 6F upon the BD cube into d square upon 4 minus y square. Here, that will be considered y1, y2, y3, that is different distance are given from top layer, okay, and distance measured from neutral axis to top layer, that is y1, y2, y3, y4, and so on, okay. But in this problem, we have to calculate shear stress at top layer from the neutral layer. The distance will be, there will be different distances will be provided. Then here, the same formula is applicable 6 into 48 into 10 raised to 3 divided by 200 into 300 cube into bracket 300 square divided by 4 minus distance is 50 square. Then after calculation we get the value. That value will get um, 5.33 into 10 raised to minus 3 Newton per mm square. That is the value. Sorry, 1.066 Newton per mm square. Okay, just do the calculation, and you can easily calculate 1.066 Newton per mm square. That is the final value you get. This is a very simple way to calculate shear stress at the top layer with respect to neutral layer. Here also we have to calculate shear stress at 150 mm from top layer. Here that value already calculated. That distance is considered from the top layer. That will be shear stress at 150 mm from top layer. That is y4. That will be equal to 150. Distance is 150 because that is half distance. That distance is y. 150 is already provided, and here we have calculated shear stress at 150. 150 minus 150, that will be equal to 0. 0. Okay, because this distance is provided. This that is total length is 300 mm. That is half. That is 150 from the neutral axis to the extreme layer. Then here shear stress we need to calculate shear stress at a distance 150 mm from the neutral layer. Means 150 minus this distance 150. Then remaining values of y, that will be equal to 0. Here 0 means at exactly neutral axis. Okay, that value is exactly neutral axis, which means that there will be neither be elongated nor shortened. Okay, there will be no effect of the load if the external load will act on the section. That layer has that layer has no effect. Okay, there will be no effect produced by the load on that layer. Okay, and that's why maximum stress will be generated. Then shear stress will be 0 at the neutral layer. Okay, because that layer neither elongated nor shortened, there will be no effect induced by the external load which act on the section. Always remember that in the neutral layer, that layer, it has no stress induced. Okay, because that stress will be neither elongated, means that there will be no effect induced by the load. Okay, that layer is said to be neutral layer. Okay, neutral layer means that will be that shear stress will be 0 at that layer. That will be maximum. Then here Q max. How to calculate Q max? Q 150, that will be 0. After putting the value, we just put up the value. Q 150, 6 into 48 into 10 raised to 3 divided by 200 into 300 Q into 300 square divided by 4 minus 0 square. Then Q50, you can calculate that value Q50. Then Q max, Q0, that will be Q max. That value we calculate, easily calculate 1.2 Newton per mm square. 1.2 Newton per mm square means we have to calculate shear stress at neutral axis. That axis will be 0 at least 150 mm from the top layer to the neutral axis. Then we just put up the value and we just calculate Q0. Okay, that will be maximum stress because maximum shear stress will be induced at the neutral layer. Then here we calculate Q50. In this problem, we have to calculate at a distance 50 mm the formula will be same 6f upon 82 in bracket d square upon 4 minus y square, then 6 into 48 into 10 raised to 3 divided by 200 into 300 2 into 300 square divided by 4 minus 50 square. Means shear stress at a distance 50 mm. We have to calculate. Then after calculation, then you will get final value 3.93 number mm square. That is the value of Q50. Once we calculate the value of Q50, then here draw the shear stress distribution diagram. How to draw shear stress distribution diagram? Here, if you see here, this is a rectangular section, and any rectangular section having stress distribution diagram will be Q max, Q0, shear stress distribution diagram. This is a very simple way to calculate. In this problem, we have to calculate shear stress at the top layer. We have to calculate shear stress at top layer and at distance 50 mm, 100 mm, 150 mm from the top layer, and also draw stress distribution diagram. Okay, that thing we have to achieve, or that thing we have to calculate in this problem. Means fourth thing we need to calculate, we have to calculate shear stress at the top layer. That distance will be 50 mm already provided from top layer. Then shear stress at 50 mm from neutral axis, shear stress at 100 mm from neutral axis, shear stress at 150 mm from neutral axis, and also draw stress distribution diagram. Means here a rectangular section having width and depth is provided. Width is 200 mm and depth is 300 mm. Then shear force is also provided. That value is 48 kilonewton. Then in this problem, first we calculate shear stress at top, that is 150 mm from neutral axis. The formula is same. Q at any distance, that will be equal to 6f upon bd cube into in bracket d square upon 4 minus y square. That formula is very important. Means we need to calculate shear stress at particular distance with respect to neutral layer. Then in that situation, or in that case, we can easily apply this formula. Shear stress at any distance, that will be equal to 6f upon bd cube into in bracket d square upon 4 minus y square. Here in this problem, first calculate shear stress at distance 150 mm from neutral layer. The value of the neutral layer, value of the distance, that is represented by y1 for sake of convenience from the neutral layer, that is 150 mm. We can easily put that value y in this problem. Then once we calculate the value of Q150, what is meaning of Q150? Shear stress at a distance 150 mm from the neutral layer. That is the meaning of Q150. Okay. Once we calculate Q150, then we calculate shear stress at a distance 50 mm from the top layer. Then calculate shear stress at 100 mm from top layer. Okay. In the same manner, we calculate that all values Q50, Q100. Then once we calculate Q150, Q50, Q100 mm, that distance, that is shear stress at a particular distance from the neutral layer. Then we calculate the Q max, means here the maximum stress will be induced at the neutral layer. Then here we also calculate shear stress at top layer. Top layer means that is 50 mm from top layer. That value is given. We can separately calculate that value. We can do separate calculation for shear stress at 50 for following this MC set of medium d square over 4 minus y square. Here also calculate all the values of shear stress at different distance from the neutral layer. Once we calculate all values, then finally you draw the stress distribution diagram for rectangular section. Okay. Here the maximum shear stress will be generated at the middle or at the neutral layer Q max. Okay. That is the nature of stress distribution diagram for the rectangular section. We also calculate some more example which is related to the same concept. Here, the same problem I will take. A beam section 100 mm by 100 mm is subjected to shear force of 60 Newton, 60 kilonewton. Determine the shear stresses induced on a layer at 50 mm above neutral axis and 25 mm below the neutral axis. Here, beam is a rectangular section. Means section is given, which is in rectangular form. Here in this rectangular form, a beam section 100 mm by 200 mm means 100 mm by 200 mm, which means that the section is a rectangular section having width 100 mm and depth 200 mm. That is the meaning of that 100 mm by 200 mm, which means that the having means that is rectangular section having width 100 mm and depth 200 mm. Clear? Next. Subjected to shear force of 60 kilonewton. Shear force is represented by a particular letter, that is capital F. F is equal to 60 kilonewton. Kilo, which means that into 10 raised to 3, means 60 into 10 raised to 3 Newton. Determine the shear stresses induced on layer at 50 mm above neutral layer. Means distance between layer and neutral axis, that is provided above the neutral axis. That distance is given 20 mm. Sorry, 50 mm and 25 mm below the neutral axis. Means 25 mm below the neutral axis. Means both distance are provided a 50 mm distance above the neutral axis to the extreme layer and 25 that distance is provided below the neutral axis. Then here we can easily calculate the values of shear stress at a distance 50 mm from neutral axis, and we have to also calculate shear stress at a distance 25 mm below the neutral axis. The formula will be same. Formula will be same. Which formula? Shear stress at any distance, that will be equal to 6F upon BD cube into in bracket B square upon 4 minus Y square. That is very important formula. In which case or in which condition you can use this formula? If a particular distance is provided in the problem and section having rectangular, that distance from the neutral layer is given, that is above or either above or neutral axis or below the neutral axis. Okay, doesn't matter. And in that case, you can easily use this formula. Q, we have to calculate shear stress at that distance. Q at any distance, that will be equal to 6F upon BD cube into in bracket D square upon 4 minus Y square. Y means a distance between neutral axis and most extreme layer. There are two layers particularly. That is, suppose this is a rectangular section. This is a top extreme layer. This is a bottom extreme layer, and this is middle one is neutral axis layer. Clear? Means if the section which is in rectangular form, then the above layer is said to be top extreme layer. The middle layer, that is that layer is which is passing through the centroid of that section, that is said to be neutral layer, and below is the bottom extreme layer. Okay. Then if the distance is suppose provided 50 mm, suppose this is the 300 mm, then this is distance is 150, and suppose 50 mm provide from top layer, then this is also create a layer. Okay, and the y is considered from neutral axis to this layer, that distance is 150 minus 50, that will be 100. Okay, that is the value of y. Okay, that y distance, how to consider, how to measure distance y from neutral axis. Suppose any layer above neutral axis is provided or from top layer is provided, particular distance given, then total distance, that is 150 minus 50, the remaining is 100, that is considered as y. Y means that distance is measured from neutral axis to the extreme layer here. Okay, if the particular distance is provided, then one more layer will be generated. Okay, and that is the extreme layer. Okay, of the y distance. Means distance from neutral axis to this layer, that will be calculated. In the same manner, if some distance is provided below the neutral axis, suppose that is 150. Okay, that is half of the x. Then suppose some distance is provided from the bottom layer is 100 mm. Then how to measure distance y? This is 150 minus 100. This distance is 50. Y is 50. Okay, means that this is very important concept. Y is a distance between the neutral layer or neutral axis and most extreme layer. In between distance is represented by a particular notation y. Okay, then once we understand the y from the above, some distance is in some example distance is provided above neutral layer or below neutral layer. Okay, but we have to understand how to measure distance y from the neutral axis, below or above neutral axis. That is very important. Then once we understand the distance, once we find out distance of y, then you can easily calculate shear stress at any distance above neutral axis or below the neutral axis. Here, the section is always rectangular form, particularly most of the time. And rectangular, if the section which is in rectangular form, you know that how to draw stress distribution diagram. The stress distribution diagram will be here. If you see already in previous problem, the maximum shear stress will be generated at the neutral axis, whereas at the top and extreme where shear stress will be 0 particularly, and if you in the middle, the shear stress will be maximum. Then in any rectangular section, the stress distribution diagram will be the same. Then here, in any type, you can easily solve such a kind of example. We have calculate shear stress at any distance with respect to the neutral here, and you can easily draw the stress distribution diagram. Okay. This is the same problem. Beam section having 100 mm by 200 mm is subjected to shear force of 60 kilonewton. Determine the shear stresses induced on the layer at a distance 50 mm above the neutral axis and 25 mm below the neutral axis. The problem will be same. In the same manner, you can calculate shear stress at distance 50 mm, and we also calculate shear stress at a distance 25 mm with respect to neutral layer. The procedure will be same. A rectangular section given, width is given, depth is given, then shear force is given,